guys. So okay, so where were we did that thing where I was trying to figure out if we can why the value is different, right? Both root are approximately the same. Now obviously numerical calculations, obviously, so I have to review first of all what is it that is happening here. So this is x times w1 plus bu1, right? And then this is x w1 plus bu1, and then it's tan x of z1 these, and then it's basically a1 times w2 plus b2. Yeah, so that's the same. Then we've got softmax. Well, we can ignore softmax for now. Let's say we can ignore softmax and say y pride is z2 np, and then here's basically saying okay, so first of all, let's see if let's I guess we'll just try to debug this first, right? So I guess first we're gonna just use the y. Like first we're gonna let's do this. So yeah, okay, because the problem is here we've got the substitution directly on the derivative. Would that work if instead of the derivative, where's the derivative, by the way? Here, W2 loss. Would it work if we would just use y pred? If I do these, if I do y pred in here, so we're no, what am I doing here in derivative? So if I do y pred and then I say y pred and then I take a look at y pred np, and then I just say the differences between y pred np and y pred, and then okay, there's even a tolerance, and then it's like difference tolerance difference, and then this is like y pred np, and this is y pred. Can I do this? Is it gonna work? So first of all, so we see if there's a difference there already, because there's so much stuff going on in there. Okay, but now the problem is truth value of relational. What the heck? Numerical derivative. The symbolic derivative. Boom. Well, so let's put it this way. That will make more sense. At least it matches the labels. But the problem is not with the numerical, the problem is with the symbolical. No, with the numerical. The symbolic derivative. 93 here. So let's just comment. That's a fucking mess. But let's just stop at y pred np. Let's not do that. Let's not calculate the derivative. The same here. Let's just let's just not do derivative. Let's just not do the loss. Let's just stay at y pred. Okay, let's just keep it simple. We stay at y pred. Then we do the substitution. We do the substitution y pred substitution dictionary derivative so print out substitute derivative. It's fine. Let's not print this out. Then we'll do the numerical stuff, and then let's do these. Let's see if that helps. let's see if that helps. Anyhow, and then we kind of walk from there. Okay, what's breaking now? Numerical data, trace back main pine, erase. I cannot determine truth value relational. Truth value numerical derivative is y pred np. Y pred. So that's in line 112. Can I, you know what, I'll just well, nothing's got substituted, first of all. Oh. So this would be substituted. That's what we want to print. That's the first thing that I'm doing wrong. Substituted. Substituted. That's why it's not working. So let's see what we get. Okay. Approximately equal. This is good. Okay, this is good. This means up to this point we're more or less at the same. So up to this point we're all more or less at the same. Yeah, that's good. It's good. Now, so now this is where it gets tricky, right? So we have the loss function. So this is where it gets tricky, and this is where we might be getting lost in the, at least y pred is this. So y pred is what is z2. At least that part, the forward pass is okay. So we know the forward pass is okay. And now what I need to do is, well, let's just leave softmax aside, and let's just get the, yeah, no, the problem is with the loss function here, right? So let's now see. We've got loss, because loss function is using y pred. Okay, and now, so now we've got loss. So now we're doing loss. So what if we do loss and loss substituted, right? Because loss just using y pred values. So it's using y true and y pred, right? So that's what we want to now check, whether the loss function is more or less, so this is loss substituted, and then numerical calculations, and now we do loss np. Oh, sorry, loss np. We don't do the derivatives, and then we compare loss and loss np. Loss substituted and loss np. So this is loss substituted, prostituted. No, sorry, I didn't say that. Loss np. Oh, I'm a child. Okay. It would be interesting if that's, oh, what? Runtime warning. Numerical none. Okay, so, okay, whoa. Oh, sorry. Loss np, and then loss substituted. This is a problem. This is definitely a problem. I mean, okay, so if that's roughly the same, what the fuck? What is going on now? 112 difference tolerance, loss np, loss substituted. Invalid NaN comparison. Why? Why is loss NP not a number? True. Where's that defined? Where's Y true NP? Is here. Okay. Y pred NP. Why is that not a number? So why is that not a number? What if I just do this? I know it's not, but like, why is that? Why is like the negative sum of that like not a number? Why is that not a number? 0, 0, none. Symbolic derivative. Numerical derivative. This is loss NP literally, and it's just saying that it's minus 0, minus 0. None. Not a number. Why? Why is that not a number? Is each of these components for some reason not a number? Well, that cannot be not a number. But the log of Y pred NP could be not a number. So for sure, well, is the log of anything not a number? Is it a 0? No, like there's definitely an invalid number, maybe an invalid input. None. Negative numbers. Negative numbers. That's a good point. Sure, because the log function is just positive. So okay, yeah, sure, but it doesn't. Minus something. Yeah, there's a negative number. There is a negative number. Okay, but then I guess that's why you do softmax. That's why you do softmax. But then let's do softmax, because softmax then translates that, right? So softmax. So for the NP stuff, the softmax stays like that. Softmax function. Okay. Okay, guys, I have 5 minutes. So Y pred. So this is basically softmax. Oh, sorry, what am I doing? No. Softmax. I think that basically does it, because then at least now that's not going to break, but obviously that's not going to be the same, so I'll just have to because what softmax will do is make sure that it's not negative, right? Yeah, exactly. Now let's reactivate softmax up here. So let's just say that's softmax. Y pred. Exactly. Let's do that. softmax is needed, then in that case, let's see. But now probably the loss functions are not going to be. They're not going to be. Oh, really? Look at these. Interesting. Okay. So the problem is a problem is with the derivative or what? I guess so. Interesting. Because here we're doing, so here it's doing these stuff. Okay, cool. Then we've at least narrowed down to the problem being the derivative. Sort of at least how it's numerically calculated and symbolically calculated. But again, symbolically speaking, the only thing we've done, or the only thing we're doing is this is div, right? It's just do an actual, like, just div, right? So let's see you next time. We're gonna focus on that part and then move on and bubble up again to sort of higher levels of abstraction where it's probably a bit more fun.